Good morning, PCMS. Here we are with part 2 of the force diagrams activity. For this activity, you're going to need a force block, which is this block of wood, and 2 spring scales. So what you have to do is we have to hook the spring scales at various locations, pull with various forces, to determine whether or not the force block moves as a result of those opposite forces. So for our first setup, for setup 1, we have a spring scale hooked onto the force block at location K, and another one at location E. Each person is going to apply 3 newtons of force on their spring scale, while the third person holds the block in place. Now we're going to release the block and see if it moves as a result of these forces. Oh, you must first make a prediction to whether or not that block is going to move. Make your prediction now. Okay, now we're going to let go of the block and watch and see if it moves. Okay, as you can see, there was no movement as a result of those forces. So the result was no movement, and the magnitude, to get the magnitude, since these are opposite forces, we subtract them. So 3 newtons minus 3 newtons, most of the time equals 0 newtons. Now, to set up 2. We again have our spring scales at location K and location E, and this time each spring scale is going to apply a force of 8 newtons. Please make a prediction to whether or not the block will move, left or right or no movement. Now we'll let go of the block and see what happens. Again, as you can see, there was no movement as a result of the spring scales. And when we say movement, we mean to the left or to the right. Yeah, the block picked up a little bit, but it's hard for us to get our angles right to pull straight away from the block.
Here.
All right, for setup 3, we again are going to use location K and location E. This time, location K is going to apply a force of 5 newtons, and location E is going to apply a force of 2 newtons. Again, please make your prediction on the movement of the block. Oh, that time when we let go, you can see that it clearly moved to the right. All right, so it moved to the right. Okay, and then now we need to calculate our resulting force. So 5 newtons minus 2 newtons usually equals 3 newtons. Okay, setup 4. We are again going to use locations K and E. This time, location K is going to apply a force of 2 newtons. Location E, a force of 8 newtons. Please make your prediction on the movement of the block now.
The movement happens very fast, so watch closely.
And go. Oh, there was a big movement to the left. Very nice. So movement to the left on that one. And then the magnitude of the resulting force, this time we'll take 8 newtons minus 2 newtons, and most of the time that gets us 6 newtons. For location 5, we need to switch and have our spring scales at location L and location J. For this time, what we're going to do is apply a force of 3 newtons to location L and a force of 9 newtons to location J. Please make a prediction on the motion of the block. Holy cow, did that sucker move?
Wowzers!
Man, so it clearly moved to the right on that one. And to calculate the resulting force on this one, since they are in the same direction, we will add them. So we take 3 newtons plus 9 newtons, and then if you carry the 1, you get 12.
Carry the 2.
Carry the 2. I'm not a math teacher. And then,
No, carry the 1.
see, I know what I'm doing. Okay, location or station setup number 6. Now we use locations D and F, just like my grades in middle school. And we apply a force of 8 newtons to location D and a force of 2 newtons to location F. Please make your prediction on the motion of the block. And man, did that move to the left. Okay, so you write that down, and to calculate the resulting force, you take 8 newtons plus 2 newtons, and you get 10. I have no idea if you carry a 1 on that one. Okay.
Yeah.
Yes, I do. Okay, I do. Okay. At setup 7, we have location K and location E again. This time on location K, we are going to apply a force of 10 newtons, and location E, a force of 5 newtons. Please predict the motion of the block. Oh boy, movement to the right. Okay, so what we should have had there was movement to the right, and then to get your resulting force, you're going to take 10 newtons minus 5 newtons, and you get, after you borrow from the 1, you get 5 newtons. Very good. So now you are ready to answer the rest of the questions for part 3. Enjoy.